So my name is Guillaume. I work at Optics, where we do OSQUERY analytics, security analytics at scale. For those that were in my security workshop last year, you may remember that I didn't work there last year. So that's a good example of how Mac admins can be good for you. They were here as sponsors. And now I'm here talking again, and I work for them. If you were in that workshop, you probably remember I love OSQUERY, so it's no coincidence that I ended up working there. But that's not my greatest achievement in the last year. So who's Canadian in the room? Who's in the Canada channel? So they're going to know what I'm going to be talking about right now. So we have this contest in Canada called the Roll Up the Rim contest. It's like a McDonald's Monopoly, kind of. And so every year we joke and people complain that I can't even win a donut. I rolled up like 200 coffees, I can never win. And so jokingly I said, oh, I won a Jeep, so the odds are good. And then I actually won the freaking Jeep. So which was a pretty good mic drop on that channel. So I figured I had to post that in here. All right, so let's get started with the real topic. So we're going to talk about a few things related to security breaches, the attack framework, and what tools we can use to help us protect our systems, detect potential intrusions. Before we do that, who in the room here would say they work in a dedicated security job? All right, that's pretty good. Everyone else, IT, and then security? All right, that makes sense. That's why I'm here. I'm trying to get away from the security people, so there's only a few of us here. But in all honesty, that's good, because you can have a security team of 1,000 people. We're just going to find more problems to fix. And the thing is, in security, there's a lot of best practices that are complete garbage. They're either outdated or they never made any sense, right? So a few examples of that would be like password expiration policies are a good example, right? The guidance for that has changed recently, but we've known for a long time that they were mostly useless. But who has to deal with a password expiration policy that generates a bunch of calls, right? Like, it's still pretty common. And so there's a lot of stuff we do to protect systems that's not based on real attacks that happen in the real world. It's just we do this because we've always done it. The other thing is, if you do penetration testing or red teaming engagements within your company, you try to simulate an adversary, but it's really hard to do that. In a penetration test, it's not very realistic. And when you do get breached in a company, it's pretty rare that the attack look like a pen test. So the MITRE attack framework is going to help us with that, because it's based in reality, which is a good thing. And we're going to review a real attack and see how it maps to the attack framework, and then how we can use OSQUERY to improve our detections on that. So my goal here is really to show you that, first of all, when you see these breach reports, they're actually useful. They're not just fun for reading and going, haha, they suck, because reality is everyone does, and it's more about what you can learn from them. And they're out there, they're free. And there's some really good tidbits of information in there. Sometimes they're just really long, right? So like the Equifax one it's a brick, but you can skip a whole bunch of stuff and get to the technical parts and just see, how would your environment withstand these types of attacks. And I'm going to be using OSQUERY to show a few examples in here, but that would be valid with any tool you currently have, right? And look at these reports, look at the MITRE attack framework, and look at what you already bought and see what you can do to improve your security posture. I see too many companies just buying 50 tools and using 5% of them. They've got a bunch of pew maps everywhere and like cool dashboards, but in reality, there's no security value. So if anyone wants to make a map based on OSQUERY data, I'm sure you could. But let's just start with 101. I know this is a Mac conference. A lot of people are familiar with OSQUERY, so I won't go super in depth on the intro. Show of hands, who uses OSQUERY? All right, so we've got a few. That's good. For those that aren't familiar with it, it's basically a way to transform your operating system in a virtual database, so you can ask anything in the form of an SQL query. It's got about 230 tables, works on Mac, Windows, and Linux. And the really important thing here is it's awesome on Mac. It's really good on Windows. But a lot of security tools you can get are usually decent on Windows, and it varies a lot on Mac and Linux, right? Like they'll still sell you the license for the same price, but the feature set is much smaller. And OSQuery is open source and very flexible. So it uses SQLite for query execution. So if you're familiar with that, writing queries for OSQuery is going to be second nature for you already before you use it. And it can run the queries either in real time, you can run them in an interactive mode, which usually is useful for developing the queries or troubleshooting, or you can run them scheduled via configuration and send the data back to a central logging environment. As I was saying, it's cross-platform. It also supports Docker APIs to be able to query about information from the containers from the host, right? So you don't need to install it within every container if you control the host, which is pretty useful. It's really fast and reliable. Of course, you can run some pretty intensive queries if you want to, but by default on its own, it's really high performance. And when I say it's flexible, it's because it's only one piece. It doesn't try to do configuration management. It doesn't come with like a logging pipeline or anything like that, but it lets you configure it over TLS. You can use a Chef or a Puppet. You can send your logs back over TLS or through syslog to a Splunk, Elastic, whatever you want. So it's just one little piece here in the architecture. Originally was made by Facebook, but as of like 3 weeks ago, the Linux Foundation owns the trademark to it, and there's a new steering committee for it. There's Grub and Zach from the Mac admins. I don't know if they're here, but they're both on the steering committee. So I'm looking forward to this year to see a lot of improvement over there. All right, so before we get started, really important, SQL is not pronounced SQL. That is a fact. So before we get started, a few key terms. So the queries are just that, SQL queries. Query packs are collections of queries, right? Here are queries I want to run at a specific interval. For example, the OSQuery project has query packs for detecting common Mac malware, for compliance, different IT things. So it's just a JSON file with a bunch of these queries in there. The output, usually it's JSON, but you could output to different formats if you wanted to. How you get it back to a central location will depend on your environment. The flags, if you hear me refer to flags, they're just configuration flags. There's many different ways you can run OSQuery. And again, there's tables and events. So what's the difference between an event table and a regular table is the event table is going to let you know what happened between two queries. So for example, there's a table with processes, but if you query that, and then 5 minutes later you query that again, if something bad ran within those 5 minutes, you won't know, right? Because it wasn't there and it's not there. But if you're using the event table for that, the next time you query, you'll see all these events come, so you won't be missing some critical events. So what it looks like is, for example, you want to see and I just realized maybe I should have written, does Apache even exist as a process? Probably HTTPD, right? Anyway, the example still works, I guess. So you're looking for a process running Apache. Well, instead of doing PS and grepping, you'll just select from processes where the process name is like Apache, which is going to return nothing because it's HTTPD. And there's no huge database that's built over time, right? Like when you request that, it's going to go get the data from the operating system. There's a database for caching and for the events, but essentially it's not a big database. It just pretends to be one. And that's cross-platform, and a lot of tables work everywhere. So who here is responsible for only Mac systems? And I'm sure you work in an environment that has other stuff, right? Like Linux servers, Windows servers. So the great thing here is if you're using this, then your security team can use the same different techniques to detect bad stuff going on across all the different platforms. So that's it. Don't need to get into it much deeper than that. You can just know pretty much everything going on using SQL queries, which could be really simple to super complex. You can do math with it. You could read databases. You can do pretty much anything. But the question is, if you can do everything, how do you start, right? It's just you have access to all this data. And how do we prepare on the Mac side? Because a lot of these breaches that we see, a lot of these frameworks, a lot of them focus on Windows because that's where most, at least, of the publicly disclosed breaches occur. So that's where the attack framework becomes really interesting. Is anyone familiar with the MITRE attack framework? pretty good correlation with the people that work in security. So MITRE is a nonprofit that gets a lot of federal funding. You probably know them from like when you see vulnerabilities with CVE numbers. They're the organization that assigns the CVE numbers. And they do a whole bunch of things, that, like common vulnerabilities, the CVE stuff, and the MITRE attack framework. So what they wanted to do was, let's build a framework that lets people protect their systems, but that's really based in reality. So it's a repository of tactics and techniques that the adversaries are going to use. So they're not best practices like, like PCI DSS will say your password should be 7 characters long, right? Which is dumb and dangerous. Well, MITRE is not going to tell you how long your password should be, but they're going to show you how an attacker will steal credentials on a Windows environment to move from one machine to another. That's the stuff that we see in real attacks. So if you compare with the more traditional type of frameworks like the NIST cybersecurity framework, which it's a good framework, but it's really meant for building a security program, right? It's like, are your executives aware? Is your risk posture good? Do you do risk analysis, blah, 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 and then how do you configure your machines with that? That's all stuff you need to do, but if you're just trying to find new ways to detect attacks right now, that won't really help you, right? That's going to help your chief security officer, the governance team, but it's not very actionable. And it has all these recommendations, right? Like, okay, you need asset management. That means you need to have all the hardware, all the software in the database, blah, blah, blah. All right, but it's really bad to have assets that you don't know about. Asset management is really important, but if you're just trying to build some new detection and secure your systems that you know you have, that's not as fast. Then we saw an improvement with the cyber kill chain registered trademark by Lockheed Martin's intelligence-driven defense. I know it's not noon yet, but I think you should have a drink. So Lockheed Martin, obviously, everything sounds super military with them. I don't know, it sounds way cooler, right? But it was a good idea because they started breaking down the attack in the steps that the attacker take, right? So they start by doing some recon, trying to find your employees on LinkedIn, for example. They'll make an exploit with a payload, try to deliver it via email, spear phishing, targeting a website they know your employees visit. Exploit the vulnerability, become persistent, communicate with the outside, and then get to their objective. And the objective is not they want domain admin or anything like that, right? They get domain admin because they want to steal your data, they want to destroy the data, whatever. So that's the last step. So the attack framework is similar to that in the sense that it also has these same steps, but it's much more detailed. Well, I guess maybe if you give Lockheed Martin a few $1 million, you probably have a very detailed version as well. So the attack framework is broken down in a huge matrix of techniques and tactics. And every single one of them has technical details and examples and a number. So I was just going to point to my confidence screen, which was really stupid. So you see right here the T1142. That's a unique identifier for this technique or tactic that attackers could have. So in this case, the keychain on a Mac is often something that attackers are going to try and abuse to get credentials. And they always include examples of prior attacks or a malware that would do that. So you can see that some of this stuff is really happening in the real world. On the Mac side, it's not as detailed yet. They started with Windows. On the Windows side, you have some very, very detailed examples. And this is all in a huge matrix. That's not even, I think that's like half of it, where like each column is, initial access, execution, all the way through, okay, they stole all of your data, what do you do now, which is the last one on the right. So you can see that to have a successful attack, an attacker will probably have a few things through most of these columns until they get to the right. And for all of these, we have the potential to detect, right? So security people, sometimes we say things like attackers only need to be right once, defenders need to be right all the time, which it's based in some reality, but I think it's mostly a way to make our job sound more important than they are. Because I'll show you in the attack we're going to look at, it's not true. Like except if you have a public website with like a SQL injection vulnerability and someone gets your entire database in 1 minute without doing anything else, it's really rare that breaches happen like this. So we have a lot of different opportunities. So another example on the Mac, right? So gatekeeper bypass. So an example that they put in there is the coin-ticker malware was using curl to download its binary. So the metadata would not be set on it, so gatekeeper would not prevent the file from being executed, right? So that's really actionable information. So every single square you saw there has that same type of information for Mac, Windows, and Linux. There's also tools like Atomic Red Team and MITRE Caldera, which are open source tools to simulate these types of techniques to see if your tools detect them. So if you start using OSQUERY to detect some of that stuff, you want to see if you set it up properly, you can run this. If you're shopping for like a new EDR tool or AV or whatever, you may want to run these tools against it to see how well they do against realistic stuff. So now let's talk about the attacks I looked at dissecting. So two big ones. I'm sure most of you are aware of at least. Oops, sorry, I'm just going to remove my mouse cursor before someone shoots me. Everyone has heard of the Equifax breach. SingHealth was another big one. And in both cases, they're pretty recent, and they both had a lot of government oversight into what happened, what went wrong, what should be improved. So I grabbed both. And the Equifax one is more interesting from a management point of view because they cover a lot of like a dysfunctional IT security team relationship kind of stuff. But from a technical point of view, it's more, you know, Apache struts, it's not patched, no one was looking at anything and it got exploited and there's no segmentation and that's the end of it, which most breaches aren't like that. Most companies don't get breached via an exposed external service. That's very different for service providers, I guess. Maybe in the world of education also, if you expose a lot of different services. But most companies, they expose like a VPN, they use cloud for email. They get breached from the inside. And the SingHealth one was exactly that. So SingHealth is a healthcare group in Singapore. And they had a huge healthcare breach, millions of records. And in the breach, they actually saw that it seemed as if people were targeting specific individuals there. They grabbed the records of the Prime Minister in Singapore? Yeah, they grabbed the files of specific politicians, probably looking for like blackmail material or whatever. And you know, while you're there, might as well grab a few million records because why not? And the report has a lot of information about how they broke in, the lateral movement that they did to get to what they wanted, which was that database of healthcare information. So it's a really good report. It's actually entertaining to read. I wouldn't say that about the Equifax one. I mean, not that they're written to be entertaining, but it was a pretty tough read. So I thought I was going to use both, but then I realized that the SingHealth one just was much better. So I was just going to use that. So if the problem with the SingHealth one, the Equifax one, and most of the public ones is there's almost never any mention of a Mac in there. And I think the reason why is because most of these companies have so many Windows machines and they have like the common vulnerability in so many of these different breaches is actually Active Directory. It's not like a vulnerability, but single sign-on with all these machines. There's always a service account that's logged in with elevated privileges, and that. Why is there a fly in here? Can I get the chipmunk instead? So there's not many Macs mentioned in these, but because MITRE has a lot of mapping between the two, we can do something that's going to be pretty good. And maybe one day it's going to be a big breach with a lot of Macs involved, and then we're going to get some interesting data. But for now, it's the best that we have, at least publicly available. So if you want to download the full report, as of the time of writing this slide, this URL was not malware, neither was this QR code, so I'll leave that up for a few seconds. And there's also a great blog post by Matt, not Max, where he actually mapped most of that report to MITRE attack. So saved me a lot of work. Thank you, Matt, and not Max. So if we look at the key events in that attack, that's like the summary diagram from the report. You have a first workstation that gets compromised. We'll talk about how later. August 23rd, 2017. And then in December, from December to June, the attacker starts moving laterally to other machines. So already you see there's some time. From these other machines that were connecting back to command and control on the internet, they tried to compromise what they call the SCM, which is their medical application, which was running on Citrix servers. So they connected to Citrix servers, and eventually they managed to connect to the database servers and pull the data. They stopped doing that on July 4th, almost a full year later, when they got kicked out. Because someone found out, like, oh, why is someone like select all from all and sending that to a weird machine? They just killed every session on SQL and they started doing incident response. But that's almost a year, right? So when we say, you know, attackers can only need to be right once, that's like 11 months you could have detected something and done proper incident response to see what have they done and how do we evict them properly from our systems, right? So there were many opportunities to do that in there. And if you really dig in the report and look at the dates, there's a few events of, there's like 2 or 3 employees in there that seem to be like very aware of what normally happens with connections and logs, and they just spot the weird stuff. And the entire thing was found just because randomly, like a database administrator sees a query in a log, and he's like, that's not normal, right? So it wasn't really detected by security controls. It was just maybe performance issues as well, right? Oh, SQL is slow. Why? You know, someone's dumping everything. So every step right there can be mapped to something in the MITRE ATT&CK framework, and some of them, especially around the workstations in the Citrix server, are really endpoint focused. Well, in the case of the Citrix server, it's like a terminal server, but it's kind of like a shared workstation in a way. So if we look at the initial entry, 2 workstations, but by the time they did incident response, one of them was long gone, so they can't look at the first one anymore. The second one started making callbacks to command and control on August 24. So that's the earliest indication of a compromise there. They saw that the malware leveraged PowerShell. All these numbers you see starting with a T are MITRE attack techniques or tactics. So PowerShell doesn't, I mean, PowerShell exists on everything now, I guess. You know, a toaster can run PowerShell, but on a Mac environment, don't see that too often. User execution just means someone got the user to run something, right? So that's totally platform independent. The initial compromise they thought was phishing or spear phishing. I always thought that was weird because I've done a lot of incident response. Well, not a lot, but I've done some pretty bad ones too. And when the original infection comes from phishing or spear phishing, every company has so much email archiving, you'll find it. Like if it was sent to a corporate email address and it was spear phishing or a bad attachment, you will find it. And they never found it, which led me to believe that it probably wasn't really phishing. They just don't know because that first machine is gone. And then I think it was CrowdStrike or Matt Not Max who said that they think it's the ruler exploit. So I don't know, anyone forced to manage Exchange environments around here? Oh, good for you. Well, there's one poor soul. The ruler exploit was a really neat exploit in the sense that you would hack someone's Outlook web access, right? Still a password. And you would basically exploit the rules engine of Exchange to create rules that when Outlook for Windows connected would be processed and would trigger code execution. So you could run code on someone's workstation by creating rules in Exchange. So it's likely that it was related to that. But we don't know for sure. So we've got all these different things that happen. So what can we do with that? Well, in OSQUERY, we've got socket events, and we know what sockets processes have opened. And we know that on August 24, there was a command and control connection that was established. So if you have a bunch of threat intel feeds and like indicators of compromises, you know like suspicious domains and bad IPs, you can totally correlate that with your data that you get from OSQUERY by just getting those events in real time in whatever you're using to centralize that, right? PowerShell logging in OSQUERY is really easy if you've got PowerShell logging enabled. And on the Mac side, I would say probably want to do something similar with the shell history and process events because you got the command line for every command that was started. And you want to monitor the processes that are running and their parents. So I'll show an example later. And then if it was the ruler exploit, the hardening of Office would have been something that you want to check with OSQUERY to be sure that it's up to par. On Mac, it's quite different because there's way fewer options on the Mac for configuring Office, but at the same time, it's sandbox, so there's fewer problems. So I'll show something on the Windows side, but how that would compare if it was a different application, for example. So you just want to see open sockets, right? And on Windows, I really like doing that with port 445 and 3389 because that's abused for lateral movement, which we'll see later. But you probably want to grab all of that unless you already have all of that in the form of a NetFlow log. And once you grab all of this, you want to match that remote address to your different threat intel feeds or to detect things like, oh, this is going to an IP I've never seen before. If you have tools that are able to identify newly registered domains and all of that, that's really useful. But again, if it's a targeted attack, chances are that was a command and control that they built just for that purpose, and you won't detect it like that right away. Over a period of a year, though, the same attacker is probably attacking other people, and people reuse, right? Being the attacker is also a job, so people reuse. So if you have a year and you've been doing that, you wouldn't have detected it on August 24th, but maybe 6 months later you would have, which was still early enough. Then on the command line and PowerShell side, if you have any Windows machines, you just enable script block logging, and then you'll get the full text of the PowerShell scripts that are run in the PowerShell events table. So a few things that I like to do there is kind of a blacklist approach, which is you just look for specific tools, right? Like Mimikatz on Windows is used to dump credentials. But if you do that, you're not going to detect Mimi dogs, right? Because it's like a specific string you're looking for, which still catches people just trying like the obvious, I just grabbed it from the internet, I'm going to run it. It's not going to catch like a nation state-backed attacker for sure. On the Windows side, I really like looking at the privileges that these PowerShell scripts are going to request. So you see methods like SE privilege enabled. Well, that looks like someone's trying to elevate privilege to maybe read memory or something like that. So that's a better way of detecting stuff on the long run than just the blacklist approach. And then on the Mac side, there's a bunch of things that malware on the Mac will do to see like, oh, are you running Little Snitch, right? So I'm going to grep for that. So look at the malware byte stuff when they find new malware, and they'll say, oh, this thing is looking to see if you have a file vault enabled or whatever. There's always command lines in there. So grab that stuff and add it to your OS queries for command lines, because you'll catch a whole bunch of stuff, because the good news on the Mac is malware doesn't need to be super advanced because people aren't really looking. And another trick I do on the Windows side that works pretty well is you look at the block count of the scripts in PowerShell, and that should work with commands also, right? So if you have an environment, you never run huge PowerShell on it, and all of a sudden you see these huge scripts that are running, it's probably because someone has something that's encoded and they have a payload within the PowerShell script. So it's like a 10K script. So wherever you're sending that, look at the trends, not just the content, the trends on the size. So for example, with PowerShell, you'd be looking at the date time, the name of the script, the path, the block count from the PowerShell events. Look at the trends there. Do the same thing with the shell history. And if you want a really good example of a good query to detect things, not just based on a blacklist approach, in one of the query packs, there's a detection called behavioral reverse shell. And what it does, and it looks a bit crazy when you look at it like that, but it's actually fairly readable. So what you're looking for is there a process that has sockets open to a remote address, and that the parent of this process is bash or sh, right? Because that looks like a script that's connecting to the internet. So maybe there's just someone grabbing anything to install from a weird source, straight into bash's root, or maybe it's malware. So these are the types of detections that you can build to respond to these questions that the MITRE attack framework has for you. In terms of parent processes, you can grab, our threat intelligence team put a little script. If you're playing with OSQUERY interactive mode and you just want to see like a process tree, that's a quick Python script to do that with the interactive version of OSQUERY. But what you want to be doing in a production environment is look at the processes that have a weird parent. So that's going to be different on Mac and Windows, but it's the same concept. So we know on Windows that a lot of malware will try to look like, well, on any platform, malware will try to look like a common system file, right? Like LSAS. Oh, I'm totally LSAS, but I have a different parent. There's many cases where there's going to be a vulnerability. In this case, maybe there's a vulnerability in Outlook, which allows someone to run code. So if you see a command line executed and the parent is outlook.exe, that's probably not great news. So that's what you want to do. You want to be querying for these executables that should not have that type of parent. So for example, if you know that the services process is running on a Windows machine, you can check it out and see what's the PID of processes. Well, I'm just going to select the PID, name, the path, blah, blah, blah. It's 568, and the parent is 476. Then manually, you'll go and say, okay, what's 476? And you see it's WinInit, which it makes sense. Services.exe on Windows, the parent should be WinInit. So what you want to know is services.exe also running with a parent that is not this one, right? So then you start making a lot of queries with negatives in them, right? And sub-queries. So this is an awesome repo that has a lot of examples for Windows, not a whole lot on the Mac side yet, but it's definitely going to get you started. Basically, in this case, what you're trying to do is, I'm looking for services that for which the parent is not WinInit. And once you have one query like that, you just copy-paste that over for cmd.exe. Well, I mean, you either do a blacklist approach where you want to know if Office is running a command line or a terminal on Mac, or this kind of approach, which is more of a whitelist approach, which is a great way of finding weird things getting spawned by different applications. And by the way, if you have any questions during the presentation, feel free to do so. We'll just toss the catch box. I don't want to wait for the end. So just if I run out of time, I'll just skip through, but I just won't answer them, but feel free at any time. And then we talked about Office. Well, on the Windows side, Office is configured usually via, could be GPOs, MDM, whatever, but it ends up in the registry. And the nice thing with the registry is you can read all of it with OSQuery. And it's kind of structured in a way that makes it logical to write queries and subqueries. And we can use wildcards in OSQuery. So for example, Office 16 configures security values for each user under a key called security. So for example, if you're looking to see will macros run on a file downloaded from the internet, that value is called block content execution from internet, and it needs to be set to 1. Well, that's a setting that usually you configure per user, not per machine. So what you want to do is you go under HKey users, /, then you do a wildcard, and OSQuery is then going to look at every single user that has that security key and give you the results, right? So in reality, you'd want to know if the key first exists, and then if it's set to 1. And you can do that with pretty much anything on the registry in Windows, but that doesn't tell you what user is configured wrong or right? Because all you have is this long registry path. But the cool thing about the registry there is that second field in the path that starts with an S, that's the SID of the user, right? So that's actually a unique identifier for the user. So what you want to do is you want to be able to match that against your users. And so the users table on OSQuery is normalized across all the different operating systems, but in the case of Windows, it uses the SID as the unique identifier. And because it's Windows, there's backslashes all over, which means we can split on that to grab just the data that we want. So in this case, what I would do is I would select the username, data, and I would split the registry path on the first /, right? So what that means right there is I'll grab the path, and whatever is after the first / and before the second /, I want that in a field called SID. And then I'll select that from a subquery where I will join that on the username. So what happens with that is instead of knowing that some random registry string that's super long is not set properly, I know that the user G with this SID has the setting configured to 1, so the user is fine, right? And so by chaining these tables, you can do some pretty powerful stuff. Now, in the case of Mac, Office is not really configurable like that, but what that would look like is more profiles, right? Like, are you pushing stuff with MDM or MCX or any third-party tool? Now, if it's still on the Windows side, if it was Ruler, you'd do exactly that, but you check for enable unsafe client mail rules, which sounds like a bad thing to turn on, right? So you would just see if that is enabled or not. On the Mac side, what you would do is look at the managed policies table. So that's an awesome way of checking if what you think you're configuring via MDM, or no matter how you're pushing configurations, is it really set to what you expected? So I would say don't look for every single setting that you push, right? That wouldn't make sense, super duplication. But pick a few of the important security settings that you configure via MDM, for example, and track them via OSQUERY. That's going to let you find out if, sometimes with inheritance or whatever, you disable something to test something, you accidentally disable it on a group or whatever, then you'll catch it. It's like a second control for your configuration. And that's really straightforward. You just get like all the values there, and you can map them as you want. But then we also have some more powerful features that we can use. So there's Augies, like I have no idea how to pronounce this. I always write it, but you can use that, which is a way to read configuration files as if they were SQL database, which is awesome on Mac and Linux, right? So for example, if you want to read your SSH configuration to see where your authorized keys are on your machines, you can actually select from that Augies table where the path is your SSHD config path. I keep pointing to my confidence screen. This is terrible. It's destroying my confidence now. So you point it to a file, and the way it works is there's a lens, which is a kind of a definition file for how to understand that configuration. And what that means now is you can parse these configuration files without writing like a bunch of shell scripts and using like Perl or awk or whatever, because it's already codified in its like an SQL table at this point. So for anything that's on a Mac that's a configuration file, there's a lot of lenses that exist already, or you could write some more if you want to check these configs, or anything that's within the SQLite database. So with OSQuery has auto table construction, it can go read a SQLite database if it has permissions to it. So if you're dealing with any app that needs to be secured and the configuration goes in the SQLite database, you can read it with that. If it's a configuration file, you can read it with that. And if it's a profile, it's super easy. So that would cover the equivalent of the registry in the case of Windows. Then our next step in the attack, that first machine is compromised. The attacker moves to the second one, and from the second one starts moving to Citrix servers, right? So we know that took place over 6 months. Malware was spread over shares, so that's a common tactic. You'll see that more on Windows than Mac. One of the main reasons is on Windows, if you have file sharing enabled and you allow traffic on that port, there's so many like admin tools that rely on that, and you have such a deep access to the system. It's not just the shares. You can use tools like PSExec to execute commands remotely and all of that. So things can go bad pretty fast. Then we had weak local admin credentials. That's also platform independent, I would say. And from there, I guess they were users. They connected to Citrix, and they tried to get that database, right? So from there, they tried a few different things. They got to a point where they had domain admin, and they couldn't download the database because domain admin didn't have privileges to the database. But the machine was a Windows machine, so if you're domain admin, you will get to it. But the thing is, that's noisy, right? Like, are you going to go and add people in the admin group of SQL or change GPOs or anything like that? Maybe you don't want to do that first, right? Especially if you're trying to stay on that environment for a year. So what they ended up doing was they found a vulnerability in the medical application, which was a web console. They managed to get the service account from there. And once you have the service account for the app, obviously that account has access to read the database because it needs to. And then they just connected with that from Citrix. Interestingly enough, apparently there was no reason for Citrix to have connectivity to the database. because they were using it to run front end, and there were application servers in the back, and these are the ones that should connect to the database. But the reason it was open was because they were deploying a lot of sysadmin tools to the same Citrix farm, not necessarily the same servers, but systems in the same environment. So people wouldn't need to install like different versions of things like SQL Studio or whatever. So they just opened everything from there, which is usually not a good idea, especially in a shared environment like that, because you know it's just a matter of time before someone is connected to the Citrix environment and starts doing a little bit of port scanning to see what they can get to. So that lateral movement occurred mostly using Windows shares. So that's port 445. If it had been a Linux environment, and we still haven't seen that like at scale with massive ransomware yet, but I think it's a matter of time before we see ransomware spreading laterally with SSH passwords or keys. So I would say you want to monitor the traffic between your workstations on these ports, because if you work in, I work in a department, let's say I work in accounting, why would my machine connect to my colleague in accounting on port 445, right? That's not something that you want to see. The good news, though, is Windows is really noisy with that. So it's really easy to catch misconfigurations in your firewalls on Windows, because as soon as someone is going to click on like My Network Places, it's like as noisy as Bonjour and all of that stuff. On Mac and Linux, it's a bit more deliberate, right? Like your Mac doesn't try to connect over SSH to every other Mac. If it does, that's probably because you're running Zoom. Sorry. Then the credentials were exploited because they weren't using a solution like Labs on Windows or Mac OS Labs, which is an awesome version for Mac. So that wasn't effective. I'll show you a little bit about that. Then you want to know, like, are your machines bound to AD or not? You can see that with OSQuery. Where are your private keys? Are they encrypted? You can see all that with OSQuery. Then for those of you that work in hybrid environments, you probably have some Windows servers. You want to know if things are logging into the Windows server in the right way, and I'll show a little bit more about that. And then could you get like SQL audit logs, any other type of logs with OSQuery? So for the lateral movement, what I like to do, especially on Windows, works on the rest, but let's say I have battle scars from the Windows lateral movement, is define what your management network is. So in this case, if and you can have as many of them as you want, right? But if in this case I was managing my systems from 10.0.99, that's the machines that should be connecting to my workstations on port 445, right? Like that's, I don't know, like your SCCM, your deployment system or whatever. And then local hosts I don't really care about. So I just want to know, is there a connection to 445 on any of these machines that was established by an IP that is not my management subnet? And usually what you'll detect with that is not malicious. It's just other machines in the same subnet or whatever. But what that tells you is if you thought that was isolated because of some control you have on your Wi-Fi, your switches, host-based firewalls, or whatever, there's something that you should fix before it happens, right? On the Windows side, rule of thumb is if you can run ps-exec from one machine to another, you have a problem. But that's an easy way of detecting it in real time as like things change. Also, for those of you that work in really large organizations with many different business units, right? Like, oh, these people use the Symantec firewall, they use the Windows firewall. It gets super complicated to track the config, but you don't need to track the config if you can detect the mistakes in the config first. Then the local admin, so that's the small excerpt from the report. So apparently, that password could be easily cracked. I don't know what the definition of cracked is. I don't know if it's like the second attempt I manually tried. Like, is that a brute force attempt? I don't know. So LA there stands for local admin, but it was also local admin that was on many different machines, and it was never used. They didn't even need it, and it was enabled, and it had that password, which also was on a bunch of deployment scripts on shares that could be read by people with lower privileges. So be sure you don't do that, obviously. Now the question is, on a Windows environment, how would you track that you're doing that properly? And on a Mac environment, well, at least you can track that if you have a local admin account that you randomize at a regular interval, you can at least see really easily with OSQuery if it was reset recently. So on Windows, you'll be using Microsoft Labs to do that, which also is configured within the registry, right? So again, with OSQuery, you can return your labs configuration really easily. And then you can get a little more detailed. You can say, well, I just want to know if my password length is less than 31 characters or whatever, because that's all configured in the registry. But that could be a mistake, because if the key doesn't exist, this is going to look good, right? Like there's no value that's lower than 31. There's just no value. So in reality, in a production environment, you would query for the key existing, and then that would be a big flag if it doesn't, and then you'd query the value. But on the Mac, who is using Mac bound to AD? Wow, that must be fun, especially around, what was it, 10.13 or 10.12? That was the first time I presented at Mac admins, and my workstation wouldn't boot my laptop because it was looking for the domain, even though it's completely disconnected. And then you turn it off 20 times, and it finally worked 1 minute before the conference, the talk, actually. So not nerve-wracking at all. But on the Mac side, we have account policy data for the local accounts. And that's a really interesting table because you have password last set time in there in Unix epoch format. So you want to track that. If you think you're randomizing these accounts with something like macOS Labs or any kind of other script, you can do that. That won't let you check that the passwords are different everywhere, right? Like I wouldn't recommend trying to start comparing password hashes with that. But all you need to do is you need to query that table and use the datetime function to convert the datetime to something that's human readable. Maybe some of you can read Unix epoch time because you're so used to it. I can't, and I shall have my revenge in 2038. So there's a lot of different functions you can use in OSQuery, like we used split before to just grab specific strings from within registry paths. You can use datetime to convert different datetimes to readable format. But you can also do mat. Even if you have some configurations that are like base 64, you can totally read something that's base 64 and decode it on the fly with a query. So you want to be just looking at that. So this is from my machine. You can see I don't reset my passwords often because it is a stupid thing to do. Then we have the connection to Citrix. So we know like that happened on the workstations. They found a local admin password. That's how they moved to that second workstation. And then they connected to Citrix. So Joanne is one of those employees I was mentioning before that seems to be really aware of what is going on, right? So they saw a live session with what they call SA here is just basically a sysadmin account, right? So they saw a highly privileged account, and it's a generic one. It's not like some sysadmin's account. It's like domain admin or whatever. No, it's not domain admin. Domain admin is DA, so it's like a really powerful account that's generic, and they saw it connecting to Citrix over RDP. And that machine also accessed a different Citrix server a few days before. And so that's when they started figuring out that something was wrong. And they always thought that these privileged accounts could not log into Citrix. They weren't supposed to log into Citrix. And the problem with that is once people start logging into different machines, even if that was not malicious, that was a totally legit thing, is you start spreading these credentials in memory on many different machines, right? So for example, if your domain admins log into a workstation to troubleshoot something, it's, well, you just gave out domain admin credentials to that workstation, so you should block that. And they thought they blocked that, but they didn't. Probably some confusion in the configuration at some point. But something that you can do, especially if you deal with terminal services environments, I find that very, very powerful, is the Windows logon sessions table tells you who's logged in, but it tells you more than that. So you can see here, okay, that's a test machine. You can see like Bob is logged in, and there's a few built-in accounts, and G is logged in, and you see the UPNs for all that. That doesn't tell you who's logged in as what, right? But there's a logon type field as well that tells you if it's an interactive logon or not. And if you have a naming convention for your accounts, that becomes really powerful, because what you want to do is say, if all my service accounts start with SVC underscore, I know that accounts that start with SVC underscore probably shouldn't be logging in interactive. And if Bob is a person, he should not be logging in as a service, right? So when you start doing that and you build queries to only return these unexpected conditions, the first kind of thing you'll find is, oh yeah, this person configured a backup job with their own account, right? And as soon as they get fired, then all the backups are going to fail. So you'll catch them like IT hygiene and stuff. But once you eliminate all the misconfigurations, or at least tune them out in your alerting, as soon as someone steals a service account and logs in interactively with it, which you thought was not possible, well, at least you're going to see it. You're going to see it right away. So the query would look like that, right? You select the UPN, logon domain, and the logon type from logon sessions, where the UPN starts with SVC underscore, and the logon type is interactive, right? So that's going to tell you your service accounts that are logged in as a person. And then you could just do the opposite, where the UPN is not like SVC underscore, and the logon type is not interactive to catch the rest. And you'll just have to tune a few, system things when you turn that on. And that's seriously a very, if you have any Windows in your environment, that's like a top 10 thing. It's that and ad blockers on Windows, it's more valuable than the entire security industry. So, and then once that person got to that machine, they started trying to connect to the SQL server. So this is valid for like any server that you have. On the Windows side, SQL server can write to Windows event log. So it's really easy to write a query that's going to just grab the specific event logs that you want. I find that specifically powerful for workstations, because who wants to send the entirety of all logs from all workstations to a central environment, right? I think the rep that sells you your license for whatever you use for central storage would say that's a good idea, but it doesn't scale, right? So on workstations, that's a great way of saying I have like these 20 different events that I want to centralize. Don't send me the rest. And it works great for servers. So for SQL servers, there's a lot of events related to modification of groups, creating new user accounts, and all of that. So that's a really easy way of grabbing that without getting the fire hose. Or maybe you keep all the stuff from the fire hose for a certain period, but these specific events, because if you remember, that attack took about a year, right? So it may be 11 months down the road that you start investigating that. And you don't want to keep everything, but there's some stuff that it really pays to still have it. So it's really easy. And then in terms of logging, the Apple logging system is supported. I don't know what's going to happen with 10.15. I think we're going to see a lot of changes. You can go read and write to syslog, which is also a pretty good way of selectively grabbing different things left and right. On Linux, SE Linux events are goldmine. And if you're a Windows admin, this is highly complementary with sysmon. So if you use all the sysinternal tools, this is a really good way to supplement them with a few specific things. And then you just centralize that over TLS, and you got what you need. So what you ultimately need to do is map your OSQuery configuration, or any tool, right? Like if you have some ADR, some EDR, some MDM configurations, use that attack framework and just go through all these columns and just check how do I block this, or if I can't block it, how do I detect it when it happens, or how do I at least log it so if something happens, I can investigate on that, right? The matrix looks huge because there's all these squares in it, right? There's like 100 things or whatever for Mac, but this is a much better solution than just grabbing everything and saying like, okay, we'll log everything and we'll figure out what to do with it later, right? That usually never works. Sometimes it's great when you do incident response because you had everything, but it's not sustainable. It's just not sustainable. So do that with the attack framework, and then read these IR reports. Even if you don't work in security, when these public reports are released, there's probably like a whole section that you can skip around, like governance of the security team. But once you get to the technical section, you didn't have to pay for it, and you see, especially if it's a company in the same industry as yours, that's like a free red team engagement that was done on your competitor, and you can benefit from that. And the worst case scenario, when you look at that, is it usually helps you justify better budgets for IT and security, because you can show how attacks happen in the real world. And if you have, does anyone here have to deal with really bad security team and argue all the time about stupid things. All right, I see smiling faces that don't want to compromise themselves. That's a great way of turning the conversation into something that's useful instead of just a bunch of like, oh, this is best practice, we do this because we do this. Like, this happens in breaches, and then we have the attack framework also based in reality. We see these different commands that the attackers will follow, and we'll block them or we'll log them with this. So it's a way of getting a security configuration that is actually helping improve security, which is the goal. And I think that for security, nothing beats the flexibility and the multi-platform support of something like OSQuery. No matter what commercial tools you currently have in place, it's great to have something that can let you access all of that data in real time, right? So for example, you may have a burning question when you find out that these machines have been connecting to Citrix. That's a little bit weird. Can I go see what processes were run on that in the last 15 minutes or whatever? And having something that runs across platforms is great. So for those of you that haven't used OSQuery yet, I highly recommend that you do so. And I mean, you're in good company. There's a lot of really good OSQuery people at Mac admins, and there's the OSQuery Slack, but also the OSQuery channel on the Mac admins that can help you with that. We'll be doing a 4-hour workshop on OSQuery at DEF CON, but the tickets sold out yesterday, so sorry. That's a douchey slide there. I forgot to remove it. But if anyone is going to be there, I know it's more of a security conference, but there's a lot of stuff that's interesting for IT people or just people that love tech. If you're going to be there, I'll try to do something to get the materials over to people that are interested. I'll probably post them to the OSQuery Slack and the OSQuery channel in the Mac admins. And with that, we've got about 15 minutes for questions. I know I'm the only thing standing between you and lunch. Not a problem if you had enough bacon this morning, like I did. Any question? Yes?
Yeah,
no.
First question.
I thought you just wanted to throw the catch box.
I do want to throw, that's why I'm going first. So you're showing a lot about what info you can get out of OSQuery to see potential vulnerabilities or what's going on.
Yep.
Is there any thoughts or comments about what vulnerabilities it opens up by having these tools in place?
So OSQuery runs locally on the machine, and it's not listening to external connections. It will connect over TLS to a centralized server if you want to. The type of vulnerability you could see with OSQuery that we've seen in the past is like if there's a vulnerability in SQLite, for example. Well, the people that are able to run queries on your system could elevate privileges, for example. The other thing is, obviously, the agent is able to read a whole bunch of stuff on the system. So if someone breaks into your centralized OSQuery environment that can do real-time queries, then they could read data. So that's going to be really interesting this summer with 10.15, because now access to a bunch of stuff is going to start getting tightened down by Apple, as it should, which is good for security. But then you're going to lose visibility unless you whitelist it with MDM. But you're totally right. I'm not a fan of having 62 different tools, because I find that if you have a tool, use it well, and then it's usually going to be worth it. But if you don't really use it, remove it, because you're just extending the attack surface. My favorite for that is data loss prevention tools, DLP, right? Like everyone has compliance that says, oh, we need DLP. DLP is good for finding like accidental mistakes, right? People emailing a credit card or whatever. But what is DLP when you think about it? It's a central point that sees all your network traffic and that already has the regular expressions for the stuff that you don't want to leak. So someone breaks into that, you've just done their job. So that's a really good question, and it's important to think about that. Any other question? Good catch.
Could you talk a little more about the events tables? I haven't used the OSQuery before, so which ones cache those events between queries and which ones don't? Yeah. Is it per table? Is there some other configuration for it?
Yes, let me just open the schema. I already had it. So there's different tables in OSQuery that screen's on the wrong side, or my keyboard is dead.
You can type in Google Chrome when you are without the toolbar.
Ah.
Thank you, Google.
So there's different tables that support events, right? So they're separate tables, and you can see in their name. And if you look at the OSQuery schema on the website, for example, if I search for event, disk events as well, I'll show you like hardware events. So hardware events, will tell you if a device was connected or disconnected or something like that. Now the trick is you need to enable, you need to set disable events to off if you want to enable events in the OSQuery configuration, and you can do that in the interactive mode if you want. I'm just going to open one from here so you don't see me making 62 typos. Oh no, there it is. I already had it. So if I do that, it says, okay, events were not enabled. So if you're just trying to play with that, then you just go disable events equals false. And so now I select all from hardware events. There's nothing, because nothing happened. And I don't know if my clicker should do that, right? Like, so I disconnected, I connected back, and there it is. Like I removed and I reconnected it. And so this is cached until you query it. So there's a bunch of different tables that have that, like processes and all that. The caveat is the support varies across operating systems for now, but it's getting pretty good.
Thanks.
All right.
Do you have a list of open source queries that you can make available that are useful?
Yeah, there's people working on a. Hold on. So there's some that we can make available. There's a few links that I had in the slides that you can check that have some good ones. There's the query packs that come with OSQuery that have some really good ones, and there's people working on making a query repo on the OSQuery website. That hopefully we see soon, so that way you have a base. But I'll make sure to give my slides to the organizers so you have all the different links. And I think my boss has a question in the back. Can someone throw the catch box real hard? No, you need a catch box.
Okay. Just wanted to say that my talk at 3:15 will share a whole bunch of queries as well.
It wasn't a question, it was just a plug.
Yeah.
Thank you. Any actual question? But yeah, do go see it at 3:15 for more malware hunting. All right. 1, 2, 3. All right, I'm calling lunch started.